Hello viewers. Now we'll discuss the scalar product or dot product and the vector product or cross product of two vectors. Here we are using one is a scalar, another is vector. So we'll two symbol A dot B between two vectors A and B, and this is A cross B. A dot B, first we'll discuss with the scalar product or that A dot B we define as magnitude of vector A, magnitude of vector B into cos theta, where theta is the angle between the vectors A and B. And it is a totally a scalar quantity. Later on this, why this is scalar, we will discuss. Now for some important results on dot product. A dot B, magnitude of A, magnitude of B, cos theta by definition. So instead of magnitude A into magnitude of B, if I write magnitude of B, then magnitude of A cos theta, so it is coming B dot A. So A dot B and B dot A are same. And here cos theta we can write as cos theta as vector A dot vector B by magnitude of A into magnitude of B. And as I said that A dot B is not a vector quantity. Here, if theta is equal to 0, then what happens? If theta is equal to 0, then A dot B is equal to magnitude of vector A into magnitude of vector B, because cos 0 degree is 1. So it is coming A into B, which is scalar quantity. A dot A, magnitude of A into magnitude of A. Again, here clearly cos theta is 0. And this is equal to write as A square. So A dot A is equal to A square. It is very important. A dot A product dot product to vector is a scalar quantity. A square. If theta is equal to pi, then dot is equal to magnitude of A, magnitude of B into cos pi, and cos pi is minus 1, so this becomes minus AB. If theta is equal to 90 degree, that is pi by 2, then A dot B is equal to A into vector B cos pi by 2, and cos pi by 2 is 0, so it is coming A, B into 0, so that is 0. So you can say that if A dot B is equal to 0, then A and B are perpendicular. Now we will discuss with the dot product of the unit vectors I, J and K. As we know that if we draw the axis, this is x-axis, y-axis and z-axis. And there we'll define unit vector I along x-axis, j cap and k cap First, see now this is by definition dot product means magnitude of I, and as the angle between I and I is 0, so we'll write cos 0 degree. Now the value of this is 1, I cap, j cap, and 1. So final result is 1. Similarly, j dot j, that is also 1, and k cap dot k cap, that is also 1. But what happens if I do the dot product of I and j? So there here the angle between I and j is 90 degree. So here I, then j, and the angle now 90 degree. So now I, magnitude of I cap is 1, magnitude of j cap is 1, and cos 90 is 0 degree. So the result is coming 0. So if I do the dot product of j dot I, we get 0. If we do the dot product of I and k, that also be 0. If we do the dot product of k and I, 0. J and k, 0. So all are 0. So now we'll start doing the dot product of two vectors A, where the components are A1 into I cap, A2 into j cap plus A3 into k cap, and another vector B, B1 into I cap, B2 into j cap, and B3 into k cap. So when you do the dot product of these two, A dot B, A1I, A2j cap plus A3k cap. This, put a bracket, and then vector B, B2j cap, and B3k cap. So now if we apply the distributive law here, A1I cap is multiplied with B1 I cap, B2 j cap, B3 k cap dot, this is plus, now multiplied with A2 with this one, so A2j cap, again B1I, B2j cap, and B3k cap plus A3k cap multiplied with B1 I cap plus B2j plus B3k cap. So A1 into B1, A1 B1 I cap dot I cap, A1 B2 I dot j, A1 B3 I dot k. So now see the first, after multiplication with A1, we are getting I dot I, which is equals to 1. So you can write it is only A1 B1, but remaining part I dot j is equals to 0 and I dot k is equals to 0. So only left is a1 b1. Similarly, when you multiply this, a2. So a2 b1 j dot I cap a2 b2 j dot j cap a3, sorry, a2 and b3, and j dot k cap. So here also this part is 0 and this part will become 0. So only left is a2 b2. And the third one plus a3 b1 j cap a3 b2 a3 and b2 k dot k cap into j cap and then a3 and b3. So here again this will be 0, this will be 0, so only left is this. So finally we are getting result a1 b1 plus a2 b2 plus a3 b3. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.